Today we're going to be solving for zeros. Okay, so we've heard this word before. We've used it as a synonym for x-intercept, right? So we can put a little parentheses there. So zeros are the same thing as x-intercepts. Where do they come from? Why are they called zeros? Let's just start with some patterns. So a number minus 5 makes 0. What's going to go in that hole to make this equation equal 0? Right, so a number minus 5 makes 0. 5. Right. Let's try it again. A number plus 9 makes 0. What goes in the hole? So what plus 9 would make 0? So think opposites, right? Negative 9. So both of these, we're just thinking in terms of opposites, right? So 5 minus 5 makes 0. Negative 9 plus 9 makes 0. Let's keep building. A number times 57 makes 0. What goes in the hole? So what times 57 would make 0? Right, that has to be 0. Okay, let's change it up. Let's say 100 times a number makes 0. What times 100 makes 0? Doesn't matter the order. Anything times 0 makes 0. So 0 times a number makes 0. 100, 1,000, 1,000,000 times 0 makes 0, right? So if this is making sense, you're in a good spot. Let's try something more complicated. X minus 3 times a number makes 0. What goes in the hole? So it doesn't matter what's here. If I have a number and I have a number times a number makes 0, and I know that this is not 0, that tells me that this has to be 0, right? So we're going to build one more time. Let's say a number times 4 makes 0, but this time I'm going to give you a big old space here, right? So this is one step closer to where we're going with this. So a number times 4 makes 0. What if that number was x plus 2? What could you figure out? So a number times 4 makes 0. So I know that whatever's under my finger has to have a value of 0. So this has to have a value of 0, and I know that this is x plus 2. I can write that x plus 2 has to be 0. So if x plus 2 makes 0, I can figure out that the x, whatever's under my finger, has to add to 2 to make 0. So what's going to make a positive 2 into a 0? That's right, a negative 2. Okay, we're going to call that x equals a solution. Okay, so that's a solution to this equation right here. Okay, so just to kind of call that out, we can draw a little triangle just so you can see sort of the thinking there. Okay, so we're halfway to doing 9th grade math. So let's do 9th grade math. All right, so we're going to take a binomial. So that's what we call anything with two terms. So we'll say x minus 2. And we're going to multiply that by another binomial, x plus 7. And we're going to say that that is our function. Okay, so f of x is just another way to say function, right? It's another way to say like a rule, right? So this is our rule or this is our function. So if I take this rule or function and I rewrite it, but I set it equal to 0, okay? The goal is going to be to figure out what x values would make this rule equal to 0, okay? So we're going to solve for 0, but I'm going to call this out. We're going to say that this and this, even though they look a little strange, right? They have x's and numbers. We're going to call this factor 1, and this we'll call factor number 2, okay? And so the big idea here is if I have two factors and I multiply them together and they're equal to 0, what that tells me is I could make this number a 0, or I could make this number a 0. So 2 factors makes 2 zeros, or the other vocabulary word is, we can call it a solution. Okay, so when we see 2 factors, that means that each of these we could turn into a 0. What does that look like? Well, if I cover up this factor and I say x minus 2 equals 0, how could I turn this x minus 2? What could go for the x in order to make this factor equivalent to 0? So I'm just going to make a little equation. X minus 2. Notice I'm covering up the second factor. I'm just going to focus on the first one. X minus 2 equals 0. And then I can do the same over here. X plus 7. How could I make that x add to 7 to make this worth 0? So I'm going to write that over here. X plus 7 makes 0. Okay? To find the solutions, and I'm going to have 2 of them, I'm just going to solve each of these equations for 0, or to find the 0, right? So I'm going to solve for x. So x minus 2 makes 0. What minus 2 makes 0? 2, right? Because if I took x and I replaced it with a 2, 2 minus 2 equals 0. And then over here, what plus 7 makes 0? Well, if it's a positive 7, to make that go down, I'm going to say that x has to be worth negative 7. We're going to call these two things solutions or zeros. So we could say that x equals 2, or x could be negative 7. And no matter what value I put in, it's going to make the whole thing worth 0, right? Because if I put a 2 here, 2 minus 2, that's a 0, times 2 plus 7, that's 9. 0 times 9 makes 0. If I take the negative 7 and I put it here, negative 7 minus 2, so negative 7, negative 2 makes a negative 9, but negative 7 plus 7 makes 0. So negative 9 times 0 makes 0. These are your zeros, or we can call them solutions. Okay, so this works if you're given a function in factored form. If you can read the opposites, right, you can separate them. What could make this 0? What could make this 0? Those values are called your zeros or your solutions.